All right, let's take a look here. Another practice AP. If f of x equals a times e to the negative ax, and a is greater than 0, then f prime of x equals. So what do we got going on here? A is greater than 0, so let's just go ahead and take the derivative like it is a constant. The derivative of e to the x is e to the x. So the derivative of a times e to the negative ax is going to be just that, times the chain rule of another negative a, which is going to get us that a times a, negative a squared, times e to the negative x. There it is. A nice quick one, as long as we understood that a was a constant greater than 0. So for what values of x does the graph of y equals 3x to the 5th plus 10x to the 4th have a point of inflection? So we're thinking point of inflection, we got to be thinking second derivative. So let's go ahead and use the power rule and find the first one. Y prime equals 15x to the 4th plus 40x cubed. Second derivative power rule. 60x cubed plus 120x squared. Looks like we can factor out that 60x squared, x plus 2. So the second derivative has zeros at 0, and let's make that the negative 2. And then we got to check it. To have a point of inflection, it's got to change from either positive negative or negative positive. So let's plug some values in. If I put a negative 10 in, I get a positive number times a negative number. If I put a negative 1 in, I get a positive number times a positive number. And if I put a positive number in, I get a positive times a positive. So the only time we have a point of inflection is when we change from concave down to concave up. There we go. Concave down, concave up. We've got a point of inflection somewhere there at negative 2. There we go. I think we've seen this one on a team test for sure. Let f be the function defined by f of x equals 2x cubed minus 3x squared minus 12x plus 18. On which of the following intervals is the graph of f both decreasing and concave up? So what are we talking about again? Both derivatives. So let's find the first derivative. F prime of x equals 6x squared minus 6x minus 12. And when is that equal to 0? I'm going to factor that 6 out and just factor. So x minus 2x plus 1. So that one is at negative 1 and 2. And if we do our signs, if we put in like a negative 3, I get a negative times a negative. If I put in a 0, I get a negative times a positive. And if I put in a large number, 4, 5, 6, I get a positive times a positive. So where is it decreasing from negative 1 to 2? So the only ones that are possible is this one, this one, this one. Yeah, I guess those three. So then we definitely got to look at the next derivative and see where it is concave up. F double prime of x is 12x minus 6. X equals 1/2. So let's take a look at the second derivative test. If I put in 0 here, I get a negative number. And if I put in any number larger than 1/2, I get a positive number. So it's concave up from 1/2 to infinity. So therefore, 1/2 is somewhere in here. It's concave up and decreasing from 1/2 to 2. There it is. All right, looking at a piecewise function here. If f is the function defined above, then f prime of -1 is, well, let's find the derivative. F prime of x is 3 when x is less than -1, and it is -2x when x is greater than or equal to -1. And we're looking at -1, so I need to put it into this one, because that's the one that has it equal. If I put a -1 in there, I get the number 2. All right. Which of the following is an equation of the line tangent to the graph of x squared minus 3xy equals 10 at the point 1, -3? So the first thing we'll notice is everything is in point slope. And everything has the 1, -3, so that's not an option. So basically, the only thing we need to find is the slope. So how do we find slope? Find the derivative. So it looks like we're going to have to implicitly derive. That's probably our best option. 2x, my bad. 2x. I've got a product rule going on here, minus 3. Derivative of the first times the second, plus the first times the derivative of the second. Got it equal to 0. So we still want to get y prime by itself. So I guess you got a few options you could do. You could distribute. I might choose to subtract the 2x over, divide by the -3. So subtract the 2x over, divide by the -3, and then I'm going to be equal to y plus x, y prime. I guess then I'd subtract the y over and divide by that x. And now I've got y prime by itself. And really it's just a matter of putting in the point, 1, -3. So I put in 1 for x. So I've got -2 over -3 over 1. And I put in the -3 for y, negative. And let's do it. So I've got 2/3 plus 3, which is going to be 11/3 over 1. So my slope is 11/3. There it is. So what did they test us on here? Implicitly deriving, product rule, and kind of plugging in numbers, really, recognizing. Not bad.